All right, so we'll go ahead and get started for today. We're happy to have Michael Blackmon here from Davidson College, who's going to present for us today on basic cloud bursting with Azure and VMware. Um, and we've kind of talked with him a little bit about things, so please, kind of per usual, keep yourself muted unless you have a question to ask, or feel free to throw the question out into the chat. Troy and I will kind of help keep an eye on chat if there's questions there. Um, and bring that up, surface that to Michael. I think Michael's okay with taking questions throughout the conversation. We'll have him kind of clarify that if you'd like to once he gets started. But we'll go to just a few minutes before the top of the hour so everybody has time to get to their next meeting. And otherwise, Michael, if you're ready to go, we will turn the time over to you, and I'll stop my screen share and you can take over.
Need to unmute myself, sorry. And share. So does that look all right?
Yep.
Okay, so I'm just going to cover VMware today. I can take questions on Azure and stuff like that, but I don't have any slides prepared for Azure just because of an issue at work that ate up most of my time. So I'll start off with some background. I work at Davidson College. And Davidson College sort of prides itself on being a liberal arts college. They sort of refuse to do the graduate school thing, and they like the idea of having a whole lot of undergraduate research and a whole lot of very adept and attuned faculty. And in particular, my job is to maintain research computing systems and instructional systems, which is sort of at Davidson College, they're a blend of back and forth research computing stuff, blends into instructional, and it's all sort of there. My official job description and job title is Instructional and Research Computing Systems Administrator. And I'm going to give you a little background about research computing at Davidson College. Over the last year, we've started a pilot program where we are beginning to integrate research computing tools and topics into the undergraduate curriculum, into portions of the undergraduate curriculum. We do this by introducing tools that support research experiences for undergraduate research and coursework. Thus far, we found providing these experiences to be extraordinarily attractive propositions to faculty. And in just the year, we've had a ton of individual projects and courses come through and use things like SLURM and all the other sort of, I guess, front ends that we've set up, where we've got like Jupyter Hub set up, and we've got Galaxy set up, and we've got some other things like that. So the context around Davidson College and cloud bursting comes from the fact that we have a bunch of compute resources that are underutilized, and we maintain, for example, 3 separate physical compute clusters. We've got one that's for enterprise applications, that's VMware based, that's just 10 ESXi hosts that are running things like Banner and Moodle and all that other stuff. We've got we've got one heterogeneous Linux cluster that's been sort of purchased piecemeal over the last 7 years using various grants, and is currently managed by faculty and their subordinate students. We're trying to change that, but it is a point of contention. In addition to that, in support of like deep learning courses and other sorts of things, we recently acquired a small GPU cluster that we were doing there, that we use and parcel out for that kind of research. So in an effort to better utilize our enterprise cluster and provide alternatives for primary investigators looking to purchase compute resources, as well as provide short-term capacity increases for courses, we're experimenting with bursting, and in particular bursting into our enterprise cluster as well as through Azure, although our experiments with Azure have been interesting. So the basic procedure for bursting or cloud bursting with SLURM is to essentially have a job that requests allocation, which requires the use of cloud nodes. Cloud nodes we'll define in a second. Then uses the suspend and resume facilities for SLURM to spin up the cloud node and make sure that it's ready. Once the cloud node is up, the controller's node information is updated along things like the IP address and any other sort of various information, and the node's Stormdemon is started. Once all of that's set up, once the nodes that have been allocated to the job check in, the job is popped off the queue if it's not sitting there and officially begins. So once the job completes and the cloud node has been idle for a specified amount of time, the idea is that the suspend and resume facilities will tear down the node and it just doesn't exist. Or it can be left around to be used later on. Cloud nodes in SLURM, these are essentially placeholder node entries, which are defined in the SLURM configuration file. Cloud nodes should not have things like the node address or the node host name set up because those are going to be specified later. Any node essentially which has state equal cloud as a part of its definition is considered a cloud node. And these nodes exist as a part of the resource pool used for allocations. However, they are not listed by utilities like sinfo, etc., until they are a part of an allocation. Like below is just a sample entry for setting up cloud resource. We've got a weight and we've got just a generic feature cloud and the state is cloud. So spinning up a cloud node requires a bit of a shimmy around starting the Stormdemon. So for the controller to recognize an instance of the Stormdemon on a cloud node when it first checks in, it is required that the cloud node's IP address and host name have been updated or can be determined using the node's name. So there are a couple of ways to do this. One is to remove the address cache for SLURM. The simplest one is to just have use scontrol to actually update the node addr or the node host name attributes. So in general, the process for spinning up a cloud node needs to go through the following. So first you boot the node, then you have some facility that moves the site-wide config to the node. You notify the SLURM controller of the node's new IP address and host name, and then you start the Stormdemon. Once the Stormdemon started, it uses a configuration to check in with the controller. The controller says, hi, how's it going? And then sets it aside for use. Or if it has jobs waiting for it, uses it that way. So the suspend and resume facilities that we were talking about a minute ago when I go through the outline of the bursting process. So SLURM can dynamically suspend and resume nodes using external tools. This is configured using essentially a bunch of things that act like prologues, but not really. So there are a couple parameters. There's the resume program, which is the executable that's going to be called when a compute needs to be started or woken up. The suspend program, which is called when it needs to be put to sleep or torn down. Suspend timeout is the maximum amount of time required for a suspended node to be ready to receive a resume request. Resume timeout, same thing same thing in the converse, in the sense that it's the maximum amount of time between when a resume node or a resume request has been issued and a node should be ready for use. If a node hasn't responded or checked in by the end of that timeout, it's considered down. Suspend time is essentially the amount of time to wait before you actually suspend an idle node. And suspend execution or exclude list is the list of nodes which are excluded. And a simple example of how this comes around is you've got a suspend program, which is essentially just a script that you've written. The resume program is configured and they're pointed to the path of that script. Suspend time, in this case, is set to 10 minutes. So if it's been idle for 10 minutes, then you try and suspend it, and you're going to exclude a certain host list or node list from being subject to suspend. So these nodes which are excluded are just never suspended. So the script mentioned over here, where I essentially set up as suspend program and resume program, these are handed parameters, and the parameters are going to be the node list for the nodes that are supposed to be suspended or resumed. So they're in that SLURM format where they've been essentially turned into a regular expression. And so there's a basic blueprint for a resume program here for a cloud bursting thing or cloud bursting instance, where you first go through, you list out the nodes, you essentially pull out their host names. Because the nodes were configured without a node address or node host name, the node name just serves as the host name. So when you essentially first call this guy, when you first call the scontrol show host names, it's just going to give you the list of node names. So for each node in the list, you go through and you essentially create a VM, and in general, just use an external utility for this. So for VMware, for example, we just clone a template. Also the possibility of creating a Pixie bootable diskless VM, which I am very interested in trying. We can't do on Azure, so sort of limited applicability outside of on-premises stuff. Or you could reuse a previously set up VM. So once the VM's booted, you're going to go through and do essentially a basic site configuration. You'll set up authorized keys, hostname, mount additional NFS shares, things like that. And finally, before you actually start the SLURM daemon on the actual node, you need to tell or communicate to the controller what the node's actual address and hostname are. That way, like we said a minute ago at the beginning, when the node checks in, the controller will recognize it and everything will be set. I can go through. The spin program, essentially it's the same thing in backwards. You start off by powering off the node. You ensure that the VM is fully deallocated, not just running in the background. You can remove the VM and reset the node host name and node there. I just added that last one because it makes sense to me. So here are some implementation details. And if there are any questions.
There's actually a question that was somebody typed inside the Google document. Curious, I think, whether or not you had tried this out yet with the newer configless SLURM functionality.
We actually run configless, and that's what we use instead of the installing and copying out the template. And actually, when I talk about the VSphere or VMware implementation, I mentioned that we use configless and very much enjoy it. Makes life a lot easier. So basic infrastructure that we have VRF, which is reserved for all things research computing. Inside that, we've put that heterogeneous Linux cluster. We've put a pair of NFS servers, some controllers, or the SLURM controllers, as well as some rudimentary service nodes like logging, log aggregation, and monitoring. In order to make sure that this infrastructure is available to our cloud nodes, we added the virtual network to vSphere. That way that when we create a virtual machine, we can just say that I want that guy's network to be wholly associated with this nascent research computing birth. And here we go. So the Spinup procedure for vSphere in this case is going to be pretty simple. So we have a blank kind of SLURM node template, which consists of cent8 SLURM 2022. And it's just not configured to start the SLURM daemon once it boots up. We've got preset credentials. So once it's booted, we go through and we update the root credentials, change the network config, make the host name reflect the host name, host machine ID, and host keys reflect that this is the new machine. We then bind it to our domain and reboot. So once we're booted, we determine the VM's IP address using the DNS entry created by our domain controller, DHCP server, and update the controller's node information. So that takes a minute for the DNS to propagate sometimes. And so we have just a simple loop where we go through and wait for it to appropriately resolve. And if it doesn't resolve in a certain amount of time, we consider the entire thing dead. Once that's all set up, we just use systemctl and start a SLURM daemon on the remote node. Again, once the SLURM daemon starts, it's going to check in with our controller. It's going to pull the SLURM configuration. Once it's pulled the configuration, it does all of its essential checks, so like general resources and its individual configuration, making sure that all the physical parameters are within spec, and things go on from there. So we create the VM by cloning a template, and then we boot it. To do this, we use a simple modification of the PY Vimoni example. It's essentially just using the Python interface to the VSphere maintenance API. And it's the external utility or external tool we mention in the Resume program cloud. Resume program cloud blueprint. We also use a script just to boot the machines, because like I've mentioned there, it's got an additional argument which when provided will actually boot the machine. So once the machine's booted and we can ping it, we use the fact that our template has a static IP address, generic host name, and pre-configured root credentials. With those known, we are and can use a Ansible Playbook to essentially go through and prepare the node to be added to the cluster in a way that it's usable. And in general, this Ansible Playbook just goes through, locks the root account password, copies over authorized keys, change the host name to reflect the provided node name, remove and regenerate node's machine ID and host keys, enable automatic mounting of various NFS resources, find the node to the AD domain, and then reboot. So provided all of that went smoothly and the node reboots, when it comes back up, we notify the controller of the node's IP address and host name. And after that, we use systemctl to start the Stormdemon. Once it's started, it checks in with the controller and is now available for any jobs that are queued that require it, or jobs that may come later. And that's pretty much the extent of cloud bursting with VMware. I didn't quite know how much detail I was supposed to go into, so I am open to questions or specifics. Any questions about specifics or anything like that?
Sure. So I'll throw some out. On the VMware side, with the when you're pulling a VM from the VMware world, do you have any time limitations for how long that VM can be allocated to the SLURM cluster, or could it be there for limitless times?
So in general, we try and keep it around 2 days. After that,
how do you accomplish that?
We set the we have it set in a partition, and as a part of that partition, we have a time limit for jobs. Once the job dies, it should essentially be idle, but now that I think about it, that doesn't actually work. So that doesn't actually work.
Okay, so a follow-up question then is, what are the sizes of the VMs you're allocating, or do you have more than one size?
We have more than one size. So we have kind of, we're trying to do a kind of graded introduction to using SLURM and things like that to students. So students will come to us and ask for resources to do or run simulations or rudimentary work that they've got through their professor or something like that. And then based on their experience level, we start ratcheting up their available resources. So we start out with 4 cores and 16 gigs. And then from there, it just doubles based on how it goes. So it goes to 8 cores, 8 actual cores, not logical cores. And we just keep doubling it until we can't have capacity, or we can't actually sustain it. So I think the max that we can do is 32 cores, 32 actual cores, and 256 gigs. And we haven't had anybody actually use that.
Hi, my name is Jesus Navarro. I have a question. I'm not sure how, it wasn't obvious to me from the presentation, but it looked like you had already, let's say, defined like host names for your cloud VMs, right? Like, let's say you already, in the SLURM config, you provide like a pool of 30, I don't know, VM host names, and you just sort of spin up the VMs as you go. Was that correct?
Yeah. Actually, in this case, we create them and pull them back. And we've actually got to answer in part the question that's in the chat along with this. We've got a resource allocation rule, I think is the name of it, that essentially binds everything, the total amount of resources that SLURM can, or that VMs for SLURM have, can get to about 50% of the actual cluster, so that we don't actually overload our VM cluster. But go back to your regular thing, we don't actually want, what am I trying to say? Yes, in some sense, we have the names, the host names set up, but we don't have the VM set up because we just don't want that stuff sitting there next to enterprise stuff.
Right. You have the name set up just so that when the VMs are up, SLURM already knows about them, right?
Yeah.
What do you do in the case that, I don't know, like say you have 20 VMs set up and then you find that, oh, I'm going to need more and you're going to need 40 now. Do you just push out a quick SLURM config update, or like what kind of infrastructure do you have set up? Because that would mean existing VMs would need to update their SLURM config, and any new ones would need to be able to get that new SLURM config as well.
That's all taken care of by the configless mode operation. So when SLURM's running config mode or configless mode, it actually, you have the ability to completely reconfigure the cluster and have the controllers push out new configuration files. So if I need to update, say I need to add another 20 nodes or node list, we can just make the change on the controller, restart the controllers, and then reconfigure the cluster using scontrol reconfigure.
Okay.
It's actually a pretty nice way to operate.
Does the configless mode introduce any like extra overhead?
Not really. I mean, it caches the configuration stuff in the spool directory for the daemon. So it's not so much overhead because it just sits there. And it's only reissued whenever there's a change or whenever the controller issues we all need to update our SLURM configurations. Once that happens, the downloaded files are modified.
Okay, yeah, one more question. I'm sorry. I think you mentioned earlier that you weren't really going to talk so much about Azure in this conversation. Is there somewhere else I can figure out like how you did this with Azure Cloud?
Yeah, so we had a bit of an issue the other day, and I ran out of time just trying to finish this up and not really knowing the direction I wanted to go or the depth I needed to go with. So I had actually intended to take this upcoming weekend, to spend the full 2 days just doing nothing but this. And I can actually add those slides in and just write them out over the next couple of days and then push that out. That way you have all the information that's there.
Okay. Thank you.
Do you feel comfortable kind of highlighting any key differences you see between the two worlds, just at a high level?
The one that is giving us pain, or is giving me pain since I'm the only one doing this, is the file server. So how do I get home directories or anything like that from our on-premises stuff to Azure in a way that's quick or is not going to impede the execution of the job, because it either times out or takes forever to, the added latency of, say, for example, loading a Conda environment or something just affects the ability of the job they're on. That is the current concern, because right now we have the NFS stuff trying to go through the tunnel that we have set up for Azure, but that is not optimal. And that has been what I've been trying to figure out.
Hey, Michael. My name's Andy Howard. I actually work on the Microsoft Azure HPC team. So I'd definitely be interested in following up afterwards with what you guys have implemented and helping address some of those blockers. Because we do actually support SLURM bursting with some of our native Microsoft products.
Really?
Yep. Azure Cycle Cloud is the main product team that I work on.
Write that down.
So definitely interested in following up after this.
Very cool.
So there's another question in the chat of how do you manage the allocations for these resources?
Strict accounts and QoS policies. So we don't let students allocate whatever they want. They have a very tight leash, a very short leash for what they can request. And we keep that, we try and give them enough flexibility to explore, but at the same time, not completely overwhelm any system that we have. So we have a pretty, I think pretty robust, I don't know if anybody else, anyway, decent account system or account hierarchy setup. The intent is for this to be merged with the heterogeneous cluster. So we needed the ability for PIs or faculty to monitor student usage and keep it under a certain thing. So if that makes any sense.
So there's a question here that I think what they're asking is for the work you're doing with Azure, how are you handling the cloud costs? Do you absorb them, pass them on? You know, and maybe this is still in the work in progress phase, but what are your thoughts, plans, or current strategies?
We vaguely intend to split them. So we will cover a certain amount of it, say like 20%, and then the researcher has to pull the remainder out of their grant. Is sort of the idea. So we give them a discount essentially on the cloud resources. And this is all an attempt to stymie. Okay, I guess this needs background. So Davidson College didn't actually have a computer science department until 2014. And at that point, physics department, the nascent computer science department, and some other places started picking up compute nodes that were just sort of unmanaged as a part of these huge grants that they got. So we've got about 15 various like compute nodes, Linux-based compute nodes just sort of sitting around. And so we're trying to get those managed by us as opposed to what we had been doing, which was having faculty and trusted students manage them. And from there, offer them something that we can sustainably handle or grow with, as opposed to having to add more rack space for these servers that were purchased forever ago without any kind of rotation policy or anything like that. If that makes any sense. So the whole idea is to incentivize them to use this cloud thing as opposed to buying the shiny new box that they can add to their collection. Hope that wasn't too frank.
Nope, that was good.
I hate to only be 30 minutes. Like I said, I can, and I will go through the management scripts and things like that and try and, yes, actually, we saw the comment in the chat. The cloud bursting stuff is more high throughput than high performance. So any kind of high performance stuff that we have is on premises. Things like the GPU cluster and stuff like that, it's just not cost effective for us to have faculty doing their research in the cloud and at the same time paying for students to bang their head against the wall on like Volterra GPU node that was purchased in AWS, or not purchased, but running in AWS. We found that it was just cheaper to buy a small GPU cluster or a small HPC cluster and just let the students use that under guided supervision, sort of with this tiered system that we're trying to implement, where they're allowed more and more resources, the more and more training they get.
So kind of in that direction, then what are you doing to kind of ensure people are sending the right type of work to the right place?
So this is our first year doing this. Right now, we are working very closely with faculty to make sure that they are communicating to the students and they are training the students in a way that allows them to not just do homework, but kind of play around a bit. I know that doesn't really answer your question, but essentially we rely on faculty to communicate directly with students. And in the case of faculty, we try and, or have been trying to train faculty to use these resources in the most effective manner. And in particular, we haven't actually pushed the Azure stuff into production. We've only got the VMware stuff. And like I said, the VMware stuff is capped by policy on the VMware side.
But are you doing anything where you're putting partition limits of job sizes to kind of steer one to being smaller, more granular HTC, or the other one can be wider, more parallel, or anything in that direction?
Yes, absolutely.
Another question in chat of what is your rough estimate of monthly cost?
So again, this is stuff that is still kind of exploratory. My monthly Azure cost is pretty minimal because it's just me at this point trying to get everything in place to offer it as a service, or to offer it as something that we can do for individual courses or researchers. But with respect to our on-premise stuff, I think the power alone can peak at about $2,000, I think is the last time I estimated it. But with respect to actual cloud cost, I do not have a real estimate for you. Just because, like I said, it's mostly just me working on it at the moment.
So if I took you back to kind of SLURM kind of question and the suspend and resume, focusing maybe on VMware where you've got more of a production environment, have you had good experience kind of with the suspend resume functionality, in the cloud's nature of the node definitions?
Yes, actually, better than I thought I would. It's been fairly consistent. We've only had a few screw ups or a few nodes fail to launch. And those were a result of an issue with, oddly enough, our Active Directory that we have since taken care of. But most of the time, go on.
No, finish what you're saying.
So we have two problems with our Active Directory. The first one is the DNS stuff doesn't update appropriately or in a timely manner. So we have an extended wait period for these things to start up. And the second one is we have way too much information in groups. There's anytime you run ID on any of the nodes, it takes a good 20 seconds for user information to come down. So that has a tendency to lock up the controller when I was trying to use the NSS SLURM plugin. And so that would actually cause connections to drop the controller and it to render node fail when trying to start a job. Because what would happen is the controller would try and get user information to proxy out to the rest of the nodes. And it would essentially block until that stuff came, but it blocked for so long that the timeouts for some of the TCP stuff exhausted and it considered the entire thing failed. It's a weird error. It was a weird thing to chase down. That's really been the major thing. That's more of a cultural thing.
So with a question I asked earlier, a little bit about how long you can have a VM checked out, let me kind of build on the mindset there. Maybe what I'm alluding, or one of the directions I'm reaching for there is if a node is basically spun up for the life cycle of a job and then torn down, and then when the next job shows up, one is stood up, have the users been receptive, or resistant to the time delay it takes to spin a node up, that whether it's seconds, a couple minutes to provision versus instant gratification, let me on right now?
Yes. Absolutely, yes. Especially the students. Faculty are a little bit more tolerant of it, but students in particular are not. And that's my fault, or in part the fault of the way that we've structured this. So we use Jupyter Hub as a means to introduce them to these things. And we have Jupyter Hub set up with batch spawner, and classes use it for just basic compute environments or basic execution environments, as well as writing, doing write-ups with things like LaTeX, because notebooks have inbuilt LaTeX. And so they get used to that instant gratification. So the idea of waiting becomes a bit of something must be wrong. So we must try something. The fact that they have to wait that long makes them think that something's wrong, in which case they send a ticket to me, and I have to explain to them that this is not what's wrong. It's just doing its thing. But that has been, like I said, mostly just the students that have had issues with that.
So maybe just because I've played with this a little bit on one of the setups we have here, one of the directions your creativity can go is to kind of say, well, I have 4 nodes, just making up an example, I have 4 nodes provisioned right now and they're running jobs. Do you almost preemptively go and spin one more up and leave it actually on but idle, just anticipating that next one as soon as that one gets, do you, because you could write something external that just looks at the queue and...
Yeah, absolutely. That is, yes. That is kind of one of the things I had envisioned with this, because that would allow me to do more interactive stuff with this kind of thing, and would allow us to have more courses and things like that that we can support basic sort of environments with and still have the interactive sort of setup. But I have not done that.
It looks like Eric has got a question here in the chat. Is there significant demand that remains even with potential bursting?
Demand in what sense? For this, the tools or the service, like just the compute resources in general? No. So VMware seems to have taken care of it for right now. But again, this is our first year doing this. So we're not comfortable saying that VMware is going to encapsulate all of the demand, or the VMware bursting is going to encapsulate all the demand that we require and provide resources that are not overburdened. So we are trying to hedge in different ways, because we have had a lot of very positive feedback from some of our pilot faculty. And as closely knit a community as the faculty is at Davidson, we expect more to come through, more demand to come through, but we don't want to. And we don't want to lock ourselves into a particular system, which is why we are trying both. I hope that answered your question. And this all works mainly because of the culture at Davidson, where they like to project the idea of a stoic old professor in a lab coat with a young, studious, and engaged student in a lab coat right next to him. And that is the education that they provide. And having that kind of embedded partnership between faculty and students really enables this stuff to make faculty excited, which in part makes students excited. So there is potential for growth, but it's mainly because of the environment that is there. So, and we are unsure.
So spinning kind of back to your plans kind of for Azure, and the idea that you work through the challenges you have there, what do you see as the vision beyond that? Where do you see yourself going?
I do not know. Right now, we are exploring what we can do and what services we can provide and what the means for which we can provide them and whether or not they would be attractive to faculty. Because I'm in a weird position that no one before my position was created really cared about aiding faculty in their research efforts or students in theirs or anything like that. And so there is a whole built up demand there, and we're just trying to explore different ways for these sort of resources to be made available to students in a way that they can learn and in part have faculty use the resources that they do when they're not in class. So I think I kind of explained that rambled off. The idea here is to set up a back and forth. So you have students using the stuff for coursework. That capacity is then allowed, or faculty is then able to use that capacity in their own research or exploratory efforts. The idea is not to set up a cluster where they actually do their research that they can do on a national supercomputer, but to have the capacity for them to explore and experiment and debug what they're trying to run. And in order for that to be sustainable, we need users more than the, say, 15 faculty that will actually make use of this stuff. So the idea is to set up students learning on these machines or on this system or using these tools. And then they further progress through their education. As they further progress through their education, they can help faculty work on their own research using the same tools. That's sort of the idea. And that sets a back and forth, but I have no idea how sustainable that actually is. Is there anything else? Again, I'm sorry to kind of stop short and not provide what I promised, but I will over the weekend finish out these slides and see if I can't get the management stuff set up on a GitHub.
No worries. I mean, we all have crises come up in our work environment, so we all understand those moments.
Yeah.
Are there other questions that we haven't touched on from anybody? Oh yeah, there is the reference there of getting the link to the slides if we could, and put it in the document.
Yeah, I will go ahead and email that out. Or I will send that to Brian and Troy. Yeah. Do you want me to go ahead and send this version of it, or do you want me to add in the Azure stuff and then send it?
Well, if you sent a link that you're updating, then the link, could be
anything.
Yep.
Yeah, cool. I'll go ahead and do that. See if I can get that set up on Dropbox. Yeah, I will.
Right. Cool. Well, if there's last call, I guess I'll make last call for any other questions of areas we'd like to put before Michael. If not, we really appreciate the time and effort, even with the crises you've been juggling. Oh, there is a question here. The question of what size of VMs are you exploring in Azure?
We haven't even settled on the size of the VMs that we're going to allow. Just because we've got the basic procedure down, but it's not an ideal, it's not performing in the way that I would expect it to, I guess is what I'm trying to say. So we haven't really settled on sizes for VMs. Right now we're sitting at what I think the B class or the B ones. Where are they? I had it written down somewhere. Anyway, I can add it to my slides. Whatever, yeah. Okay.
Again, we really appreciate the time and effort you put into this, especially with the crises you're dealing with, but appreciate everybody's time and attendance today. But we can wrap this up and give everybody back a few minutes back to their day and give you a little bit of time before probably your next, Zoom meeting.
Yep, 2:30 actually. Awesome.
Thanks everybody.
And I will add the, can I actually edit I can edit the document, can't I? So yep, I will absolutely add a Dropbox link for the slides in there.
Great.
Cool. Thank you.
Yep.
Thank you for
Thanks,
having me.
everybody.